In this animation, we will evaluate the definite integral of x squared from 0 to 2. This process involves understanding Riemann sums and their relation to definite integrals. Let's dive in. A definite integral represents the signed area under the curve of a function between two limits. To approximate the area under the function f of x equals x squared from 0 to 2, we can use Riemann sums, which involve dividing the interval 0, 2 into n subintervals and using right endpoints to create rectangles. This division allows us to estimate the total signed area under the curve. To set up the Riemann sum, we first divide the interval into n subintervals of equal width. This step helps us break down the curve into manageable sections for more accurate calculations. Then, we calculate the right endpoint for each subinterval, determining where the rectangles touch the curve at its highest point. Calculating the areas of the rectangles involves determining the area of each rectangle and summing these areas to obtain the Riemann sum. This summation process helps us estimate the total area under the curve by adding the areas of all the rectangles formed using the right endpoints. In the final step, we evaluate the sum using a specific formula and find that the definite integral is equal to 8/3. This calculation involves a deeper understanding of the relationships between the individual rectangle areas and the overall definite integral, showcasing the power of mathematical techniques in solving real-world problems. Definite integrals have practical applications in various fields such as calculating the total distance traveled over time and analyzing areas in economics. Understanding the concept of definite integrals enables us to make precise calculations in scenarios where accumulated values or areas need to be determined accurately. To summarize, we evaluate